So it's my great pleasure to introduce Joyce Nakatumba-Nabende and also Andrew Katumba, who are going to talk about they're going to have a responsible AI masterclass today, and in particular focus on bias in machine translation. I'm really looking forward to this second in the series of masterclasses. So please, Joyce, take it away.
Thank you, David. Good morning, everyone. Thanks again for coming to join our masterclass on responsible AI. I feel like it's a huge responsibility because responsible AI is so wide. But we'll try to decipher this, especially around bias in machine translation. That's going to be the focus. So the outline is we'll have an introduction because probably not everyone knows what bias is and where we're coming from. And then we'll talk about gender bias. We want to actually specifically focus on gender bias. And then also look at gender bias evaluation and mitigation, and we'll have the demo. So I'll take you through the theory part of the work. And then my colleague, Andrew, will come in and we go through the demo and the notebook. And we are hoping it's as interesting as it is, as it was for us going through this. Yeah, so we have some definitions because we really want to get grounded and understand where we're coming from. So my background is in computer science. So if I get any social term wrong, forgive me because of my background. But yeah, I thought we'd get started by understanding what bias is, such we are all on the same page, and then get into gender bias, and then get into gender bias for machine translation. So everyone defines bias differently. There are so many definitions out there. But bias can be defined as the divergence from an ideal or expected value, which can occur if you bring it down to the models. If the models rely on cues or strategies which can be suspicious or which can be unintended in order to produce some outputs. So at a higher level, there's something that is expected, but if you differ from what is expected, then there's some sort of bias that could occur. But when we look at computer systems, there's a term that was defined in the paper by Friedman and the other author in 1996 that defines biases in computer systems where they systematically and unfairly discriminate against certain individuals or groups of individuals in favor of others. And I think for many of the examples that we have seen, or many of the ideas or many of the papers that are out there that talk about bias, I think they really bring out this definition quite well because there's always some sort of unfair discrimination, for example, maybe in job interviews, or unfair discrimination in sending people to jail, where certain groups, certain individuals are, discriminated in favor of other individuals. So that's what usually happens. So if a system discriminates unfairly, it will deny an opportunity or a good, or it will give out an undesired outcome to an individual or groups of individuals, and this is usually unreasonable or inappropriate in a way, and we're going to see why this is the case. So when we are analyzing bias, it's really a process that requires to identify what is this unfairness, what do we deem as harmful behavior? How is this unfairness defined and to whom? Because we said that there were social groups that are discriminated. And so when we are defining it, we look at the people, we look at how this is done, and we look at generally the whole area of what has actually been unfairly distributed out to people. So let me start with an example. So I hope people haven't seen it before, so it makes sense anyhow. So a man and his son are in a terrible accident and they are rushed to a hospital in critical care. The doctor looks at the boy and exclaims, "I cannot operate on this boy, he's my son." So the question is, how can this be? Any brilliant answers?
Well, they're gay.
Oh, wow. Wow. So it's a male. So the doctor is a male, right? Any other brilliant answer? Which female? The doctor is a female, but they're saying how is the doctor a female? How is the doctor related to the boy, to the son? She's the mother. The mother is the doctor. Okay, so you guys are bringing that.
She's not the mother.
Yeah. Okay. Not brilliant. All right. So the people who said that it's the mother, the female, are the correct ones. It's a female doctor. It's a female doctor. But the first answer we got didn't go that direction. It said it was a male. And yeah, so I guess even just looking at it, the female part wouldn't come to our brains first because we don't expect the doctor to be female, right? We always think doctors are males. And so we compare the female doctor to a doctor. Who's our first doctor? Our first doctor is a male. That's how we think about things in society. So this was a study done by Boston University. And when they gave this example, the majority of the test subjects overlooked the possibility that the doctor is a she, including men, women, even the feminists. They, thought it was what David said. Yeah, most likely, or the grandfather, I don't know, something like that. Yeah. So I guess we can already see that there's some sort of bias implicit in us. So bring it back to machine learning. So when we think about machine learning, where do we start? We always start with training data. We collect training data. We annotate this data. Then we train our models as the next step. After which our model is going to give us an output. In this case, the output we are focusing on is translation, translating from English to Swedish. But one language to another, or we understand maybe the sentiment. What's the sentiment from the text? What's the sentiment from the tweet that has been posted on social media? So the model gives us an output. And then we, the people, see this output from the model. So along this machine learning pipeline, there are biases that are introduced, as you can see, because there are different steps that we are looking at. So if we look at the data, always the first bias that occurs is because the data is coming from us, the humans, right? So we're the ones creating the data. We're the ones probably who are annotating the data. So there are always human biases in the data. And the study by Google gives very many examples. I'll share the link, I think, in the next slide that talks about all the different types of biases that are existing around the training data. Several of them. We'll try to go through some that are important for this class. So we have these biases in the data. But we also have the biases in the collection, in the annotation. If you're going to do a sample, how sure are you that your sample is representative? How sure are you that you have collected all the data that is required? There are very many aspects that have to be taken into consideration in the collection and the annotation of the data. And all these things could introduce bias in the data. And the model is learning from the data. So then the bias moves from the data to the model and out to the output that the humans are seeing. So if we look at the data, some of the things that are important are examples are like the reporting bias. What people share is usually not a reflection of what happens in the real world. That could be an issue. If we look at selection bias, does the selection reflect a random sample? If we look at out-group homogeneity bias, people tend to see out-group members as more alike than in-group members when we are trying to compare attitudes, values, personality traits, and other characteristics. But when we are collecting data, we don't actually think that these things are going to affect the data that we are collecting. If it's about confirmation bias, it's the tendency to search for, you interpret, or you favor, or you recall information in a way that will actually confirm your belief or hypothesis, because you have a thought, you have a belief. So you want to confirm that even if you think it's not true, or the truth is different from what you're confirming, you'll say, oh, that's what I will report because I think it's in line with what I think, or it's in line with my belief. Maybe it didn't happen like that. When we do the interpretation, sometimes we can overgeneralize. We can come to a conclusion based on information that's too general, or it's not specific enough. Or we might even have automation bias, where humans favor suggestions from automated decision-making systems, even if it's contradictory, because we think that the system, can better be trusted than what the humans can do. So these are some lists of examples of biases that are available and were developed by Google. So if we look at English, if we said we're going to train a machine learning model that's able to recognize Englishes in the world, I think it's strange when you're on Zoom and then you try to put the caption generation, right? And or even on the phone, when we try to speak to Siri or to go to YouTube and then you put the voice and you want to search. The way we speak English in the African context, of course, it's very different, right? Our accent is very different. And so when we go to search, my daughter gets the phone and she searches, and because of the influence of the cartoons and everything, her accent is, more or less close to what the cartoons are saying. So maybe when she searches for something, that's easier to recognize. When I speak, my accent is completely different. So there are so many Englishes that are out here. When Chika speaks, her accent is different, right? We have different accents on the African continent. And so when we get the data to train our English NLP models, is it representative of all the Englishes that are out there? Because imagine every continent has English speakers. Are we able to capture this diversity as we are training our models? So there's always this bias in the data, but we realize that there are so many systems, so many tools that are out there that are provided on the phones, that are provided on the different platforms that we interact with, that they actually are not working for us or are not working for all the different variations in accents that we have in the world. So if we look at selection bias as an example, when we select something, have we taken consideration that it reflects a random sample? Much of the reasons why we're doing gender bias, especially females, is because when we look at men are overrepresented in web-based news articles, men are represented in Twitter conversations. I think I forgot to put something around Wikipedia. When you look at Wikipedia, the content moderators for Wikipedia are all men, or at least to a greater percentage are men. And that influences what is put out there, that influences what is moderated and put out there. So at a certain point, when we look at the data that's available on the internet, there's a higher representation of the views of the men compared to the female. So that could be a source of bias. If it's sample bias, we have underrepresentation. Here, our training data set doesn't accurately represent the intended real world application. We expect that the population has both males and females, but when we sample and we take out only the male images and we use that to train our face recognition models or male recordings, and we use that to train our speech recognition models, then that's not representative enough, because when we try to test it out on female Black faces, then we'll have an error. It will not be able to recognize that. I hope we all know this study that recognized females, that recognized Blacks as gorillas. I think it was based on ImageNet, right? Because the training data wasn't representative enough. And it's even not just important to say males, females. It's even important that there's intersectionality, that we introduce other aspects. Are they females? Yes. Are they males? Yes. Are they Black females? Are they Black males? Because we are all not the same in the world. We're doing a study that's trying to understand speech recognition models and understanding gender biases. How do the models work on female voices compared to male voices? Because we think that's an important aspect to consider, even for a low resource language like Luganda that we are looking at, because we want to understand, is there any underrepresentation of the data that we use for training our models? Then exclusion bias, here it occurs when we exclude some features or groups from a data set based on the assumption that they are not relevant, right? Again, we can think that if we had a sample and the sample has both positive and neutral sentiments, maybe we think the negative sentiments are not very important. Let's not include them in our data, because we want to build an algorithm that's maybe not focusing on the negative aspects that are being mentioned out there. But when we do that, then our sample is excluding a certain group of views or a certain group of people that might not be important, but we think is not important. But when we train and we try to test our model, then the data set that we have doesn't include all the relevant features that are important. Because when we're looking at sentiment, it's not just positive and neutral that's important. There's always also a negative sentiment. But if we pick data that doesn't represent everything, then we introduce an exclusion bias in the data. Measurement bias, this can be caused by the poor measurement of the outcomes that we are measuring. So the data sets end up being skewed in specific directions. And so this is just an example of a training data set. And then we try to look at what is the predicted level, what's the actual level that we look at there. And so we realize that most of the times we have the actual levels differing from what we had in the training data set, because we had some sort of measurement bias because the data sets aren't representative enough as we use them to train the machine learning model. So this is an example that comes from the labels, because we said one of the main places where biases come in is in the labels. And so this data set was given to people to annotate it, right? And when people annotated the data sets, they annotated with their world views of how things take place. So they were given images and they were told, put a label that you think is representative of this image. So we can see that for the first three, people were saying it's a bride, it's a ceremony, it's a man, it's a groom. And I wanted to ask Chika, is the last paragraph also representative of a wedding or not? I think it's Nigerian. This it's wedding, yeah. So, but yeah, but it was annotated as people and persons. And yet in the Nigerian culture, weddings can also take place, yeah, traditional wedding without the white gown. And so because of the worldview, perhaps the people who annotated didn't know about that culture, right? So they weren't aware. And so they didn't put in that view as they were annotating the data. And so when you go and you have your machine learning model trained on this data and you search and you say, I want an image of a wedding, or maybe you throw this image into a model. Right now we have LLMs that you throw an image and it's able to give you something about the image, or provide a description about the image. It will not say that the last image is about a wedding. It will just say it's a male and a female, maybe smartly dressed people, but it won't associate that with wedding. So we realize that with these labels, with the humans, we can have bias occurring. And then the one that's common is the prejudice bias. Sometimes they're called stereotypes, which are about the beliefs of people or persons or things, where the algorithm is fed with data that shows, for example, that men are mainly programmers, while women are mainly in the kitchen cooking. So that's what we provide the model, because anyway, all the articles that are written out there, or most of them that are written out there, you know, would say that programming is for males, cooking, caretaking, you know, looking after babies is for the female. And so when we feed that into the algorithm, the models are able to learn that and make a prediction. When you type in what's a programmer, they will definitely tell you it's a male. Who does cooking, they'll tell you it's a female. So this stereotype is a very big issue that people have spent a lot of time studying in how to deal with it in NLP. So when we look at algorithms themselves, sometimes also we have the biases, not just with the data, but with the algorithms, where we have unjust and fair treatment of people that's related to, as I said, we move beyond gender, because there are so many other intersectionality things that we think about, like race, income, sexual orientation, religion, and so many other characteristics that can be associated with discrimination and marginalization. And so when we have these things occurring in the world, anyway, they are occurring. If we get the data that's based on that, put it into the models, then the algorithms, as they're trying to do their predictions, they're already going to be associated with this discrimination, and this will manifest in the decision-making of the different algorithms. And there are several examples that have been out there of systems that have been trained, and the systems have been biased, maybe because of the income of people, or because of the race of people, and they have not been offered a social service because of the discrimination that they think is existing already in the world. So when we look back at our machine learning pipeline, again, we have human biases at every point, at the training, because of the annotation, the model training, what the model gives out, what people see, we have bias, and then this is fed back into the training data. So the biased data created from the process can become the new trained data, and then it perpetuates the bias throughout the system. So this human data will perpetuate the human biases that are existing. And then as the machine learning models learn from the human data, the result is going to be a bias network effect. So it's called bias laundering. It just goes through the machine learning model and back, and it continues on and on as well. And this also just says the sources of bias, of course, that are related to machine learning annotation, with selecting that comes into the data, what we take out and represent into our models, and basically the whole design. So there are biases that can occur at each of these different stages as we build our models. So now that we have understood, I hope we have understood what bias is at this point, right? Or maybe each one of us has examples where we have seen bias. Can we take a 5-minute break and listen from the audience of any examples that we have had?
Do you want in applications of machine learning?
Yes, I think even better. or your lives, I guess. Your lives would be good to start there. Yeah, before machine learning. Any reflections? Yes. Yes. No, it shouldn't be gender bias, because I'm going to gender bias next. So no gender bias.
Recently, I had an assignment, and the lecturer gave us the website where we could generate AI generated photos. And my target user was Black female. And I went through like 50 photos, and I didn't see somebody that looked like me. And I got very upset. And even with the Black male, it still didn't look like my complexion. It was very, very light skin Black male. So that was one example where I saw that.
Yeah, that's a good example. Any other examples? Yes.
Voice recognition.
Yeah.
And our inaugurals are in YouTube, and I just look at how people talk, and there is always the text, whatever we are saying.
Yeah.
It is ridiculously wrong sometimes, depending on the person who is talking.
Yeah, I think those are like even the Zoom captions. They will not recognize what we're saying or how we speak. Yeah.
I can say one.
Yes, please, Chika.
Like I said something about iPhone yesterday.
Yes, you did. Yes.
The people that designed this iPhone didn't use most of the blacks to train their data, because I use my face and my second daughter's face to use it as well. So it's not supposed to be, it's supposed to be unique.
Yeah. So
the problem there is that the data they use is the one that is peculiar, that's the one they are used to. So we are supposed to be the ones to do. So yes, I'm not sure this bias thing will go away. I still don't know how it is clear it, even though we're trying to reduce it, but even in real life, you have preferences.
Yes.
So let's see, this machine learning bias.
Andrew is the hero of the day. Any other examples?
There was one.
Yes.
Also about the face recognition, I tried on social media.
Yeah.
There is this which says your future baby, and then you put the face of your husband and yourself, and then you want to predict how the baby will look like. I got any that in. Each time they get me a white baby.
Wow.
Question from one of the online participants.
Yes,
is there
Francisca.
any bias in recording African names versus others in you naming the US names?
Yes, I think our names are very, very unique and different. And if you were to even train a model that's able to recognize which tribe the person comes from based on the names, because our names, you realize my name is similar to Andrew's name because we are from the same tribe, right? So it's that complicated that you can actually identify people from the same tribe based on their names. Yeah, and I don't think their systems, they will definitely fail, on African names. Yes. Yes.
Uniqueness in Africa is very minor. We didn't consider all of this. I don't know whether we start afresh.
We'll get there.
Yeah, it's just a completely different questions. I mean, I can understand exactly the bias from the data. You know, if you are not collecting properly the data fairly, might have be a bias. But I would like to know your perspective how the algorithm or a model can create a bias.
Oh, okay. How it can create the bias. So we're going to talk about that through looking at the word embeddings. We're going to speak about that, and we'll also evaluate at the model level. Yeah, moving on. Yes. Okay, so let's continue. Thanks again. It's good to hear your perspectives about this. All right. So gender bias, because that's our focus for today, and because gender bias is the most prevalent bias that is out there in our societies. So it's defined as the dominance or the preference in particular contexts. For example, looking at occupations or amongst primary social roles of one gender over another gender. I think the example that we gave of males being programmers and females being cooks, already that shows the gender bias, that shows the preference in particular context where we think one group is signed out for one role while another group is signed out for another role. So gender bias is exhibited in different parts of an NLP system. We can look at it in the training data, in the resources, in the pre-trained models, for example, looking at the word embeddings or associations of words and the algorithms. So when you have text that you're going to put into your NLP system, it's usually put into vectors or word embeddings. And these word embeddings are able to show the associations between the words that you have in the text. So you can, for example, associate a male to a woman if it's male, female, a king to a queen, or walking to walked if it was an association based on the verb, or swimming to swam, or if it's an association based on the country, we can be able to associate different cities with their countries with their capital cities, etc. So there's always that embedding space where we find these associations. And so when you give it data that's already having the bias, it's going to learn these associations in the data that we feed into our machine learning models. So because we have the biases in the society, this will translate into biases in the AI training data. And so this way, the social biases, the stereotypes find their way into the AI systems. And so when we have the application will definitely perpetuate the bias. I think we've already seen that, even if it were any other bias. So this propagation of gender bias will cause the danger of reinforcing damaging stereotypes in any downstream application that we will have. We've seen systems that have been designed to, for example, take people's applications and then give a reject on whether they qualify for the job or not. And there have been examples of where job applications have been rejected on the fact that there was a word that says female in the application just because of that stereotype, saying, oh, we don't want females. They've written about themselves in the CV, so let's that reject at that point. So in downstream applications, once we have this bias, then that is something that's perpetuated. So this has real world consequences around, for example, the resume filtering systems, yes, that I just talked about, giving preference to male applicants when the factor is about the gender. Yet we definitely know that gender shouldn't be a factor that we look at when we are trying to employ people, because there's a lot more than that. So there's a researcher in the UK called Kate who talked about the trouble with bias and tried to look and break down these harms that come from a biased system. And she broke them down into two. The first one is the allocation harms, which is an economic issue when a system unfairly allocates or withholds opportunities or resources to certain groups over others. So it's a harm that can come out of a biased system. And so this is reflected when the models perform better on the data that's associated with a majority gender. So if you look, for example, with data that you can get and you realize that the data is focusing on certain things being done more by males compared to females, then there's already that bias that is associated and given out into the models or the system that you'd probably train, because you're thinking that in this particular kind of data or in this particular kind of system, there's just one particular group that's signed out to do it. So in terms of allocation, the system can withhold opportunities to certain groups. Another harm is the representation harm, where the system will detract from the representation of social groups and their identities. And this will affect the attitudes and the beliefs that we have out of the systems that we are training. So when we have associations between genders with certain concepts that are captured in the word embeddings and the model parameters, this is going to be reflected out when we actually do testing. So this representation harms, they will arise in NLP systems because we have, as I said, the statistical patterns that are occurring in the training data that we use for building out the representations in the model. So when we have these statistical patterns or these associations coming out, because the data that we have already had these in the system, in the real world, when we have them coming out in the models and they're represented, then the models are able to learn these and then, put them out, or they're going to be captured and represented in the word embeddings and the parameters that we use in our models. So representation bias can be described further into 4 aspects, because we're going to see an example where each of these aspects actually speaks to things that, or examples of systems that are actually out there. So the first one is denigration, that refers to the use of culturally or historical derogatory terms that are existing in real life. We have the stereotype. I think this one we know, that enforces the social stereotypes that are existing in systems. Then we have recognition bias that gives an algorithm inaccuracy in recognition tasks, and then underrepresentation that's disappropriately has a low representation of specific groups. So when we look at this representation bias, we have examples here based on that paper for different NLP tasks. So the first one is a machine translation task, which we're going to look at, where we translate "he is a nurse, she is a doctor" to Hungarian and back to English. When we translate back, the model knows that definitely the nurse is a she, and definitely the doctor is a he. So that really occurs back when we are translating from another language to English. So for that task of machine translation, the representation biases that are represented as stereotyping and recognition. If we look at, for example, speech recognition, I like speech recognition, of course, because many of the models work better with male voices than female voices. We haven't even gone to the accents, but just the male versus the female. When a study was done, it was able to show that it works better for males versus females, and that's a representation bias and a recognition, a recognition and under-representation representation of bias. Then when we look at language models, definitely he's a doctor, has a higher conditional likelihood than she is a doctor, of course. So when we are using our language model to translate back, definitely the probability will be given higher to he is a doctor as we do this translation. Then I think I talked about already this word embedding space, where a man is associated to woman, computer programmer, homemaker, which means computer programmer can be associated more with the men, while the homemaker is associated more with the female. So these are automatically generated by the models that are trained on biased word embedding. So the models are able to learn this and pick up these biases and under word embeddings, and this really is a representation bias for all the 4 categories in the context of gender. So before GPT became very good, because if you try this right now in GPT-4, you'll definitely get a good response, but there was bias that was existing. And then over time, this was in 2019, when we would put in prompts into the language model, this is what was generated because there were associations in the model. So you typed "a man worked as," the response was "a car salesman at the local Walmart." I guess it's based on US examples. We don't have Walmart in Uganda or Africa. Then the woman worked as a prostitute under the name of something. When you talk about the black man worked as a pimp. What did the white man do? The white man worked as a police officer, a judge, a prosecutor, the president of the US. The gay person was known for his love for dancing, but he also did drugs. Like, what was the tradition for? I don't know. Anyhow,
That's why he wasn't a doctor.
No, he wasn't a doctor. They had to really justify the model. The straight person was known for his ability to find his own voice and speak clearly. Like, why would you associate that? Anyhow, so the models were biased because these were the things that were existing out there. These were the things that were being written, and our language model was able to pick out these different associations and generate them out. These have improved. When ChatGPT came out, yeah, there was a lot of work from the social and the ethical people, and over time, the models have been improved because there's the human reinforcement learning to improve these models. So these days, when you ask it something, it's like, I will not discriminate. We should not ask about Black people. It says something, it has something, but we're still targeting, where we have ways of tricking the model and asking it maybe in a context, but the model is also still able to give out these things. So I think it's not completely eliminated. It's really good to do this ethical consideration of the models to understand biases. So I will give an example in machine translation. This is for Swahili. Again, I don't speak Swahili, so the Kenyans, I hope I am correct. So the English word is, he is a hospital nurse. The Swahili translation is that. When you take that same translation and you put it into the model, it will switch the gender and say, she is a hospital nurse. Yet when it was English to Swahili, it was a he. Something that's slightly related, we just saw it yesterday with Andrew. So this is in Luganda, so I speak Luganda, so I shall say what it means. So the first one is an English, is a Luganda term that says, Ngoye. So what that means is that he's washing clothes. So the problem, I think I'll talk about it with languages, we don't have pronouns in our languages. We are genderless. We don't have this he, she in the local language. So when we put in that, we said, he washes clothes. It could have said she washes clothes, right? Because my Luganda sentence has no gender. But what is the first gender that the model picks? The first gender the model picks is a he. Then the model says he washes his clothes. Then the next one, the literal meaning of the next one is he washes his clothes every day. So the first one is just he washes clothes. The next one is he washes clothes every day. It could have been she washes clothes every day. I just added one word to the model. I didn't even delete the whole sentence. We just added one word to the model, to the sentence. And automatically the model switched the gender and said she washes her clothes every day. Why is it that a man washes once and a female washes every day? Yeah, it's not fair. It's not fair, but with just one word, you realize how much bias there is, right? That even with the words that you put in, automatically it's able to pick that out, switch this out. We tried it multiple times. Yeah, that's a responsive gap. Yeah, which I think was interesting for us. Anyhow, so that's machine translation. So as Chika said, how do we solve these things with our local languages in the African context? I think it's a very big gap. There's a lot of research that can be done. All right, quiz time. So which of the following statements do you consider to reflect gender bias? 1, she was lucky to be appointed as an executive. 2, when she challenged the leader's statement so directly, I was surprised. We could never challenge our leaders like that 10 years ago. 3, she is not in her office. She must have gone out for shopping. D, all of the above.
Did we discuss with a friend or?
Yeah, discuss with a friend. I see some random answers coming up when you don't discuss. No, any context. No, there's no Africa here. No, 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 no. There's no Africa.
Joyce, if you get a question, can you repeat it? People look online, they can't hear the questions that come in, so
Yeah.
say, oh, this person is asking.
I'll do that. Yeah.
Especially when we got such good examples. of the,
I'll do that. Thanks. All right, let's hear your responses. Yes. Yes, you can go. Someone says it's A, C, and D.
You think that normal sentences, there is a reverse clause.
Thanks. Any other answer?
Yes, we said A and C, but you know that B is a little bit, you know, the leader can be a female. But the only thing is, why it will still be part of it is that means females never speak up to their leaders, no matter the gender, before, you understand? So, but now they're doing it, they said 10 years ago. So that recently they are getting the new page to speak.
Okay. So Chika is bringing out the fact that it says that it's a she who's challenging the leader statement because previously women would never stand up, right? To their leaders. So you think it's A, B, all of the above?
Yes.
That B was tricky, but I think it's
Yeah.
part of it.
I thought it was A and C, obviously, right? Yeah, because we are associating a female being appointed as an executive to the fact that there's lack, like we wouldn't work our way to get there. And then the C was she's gone shopping. Couldn't we have gone to do a parliament meeting or something? I don't know. Yeah, so I think A and C are obvious, but B, if you explain it like that, you know, when women were never allowed to speak out, now they can speak out, perhaps that could be a form that reflects gender bias as well in the statement. Again, thanks for your discussions. So when we want to understand, yes, sorry, please go ahead.
Would be still qualify if the second part is not there?
Maybe the second part makes it not qualify. And if it were just that she challenged the leader's statement so directly, maybe. Yes.
Without the second part.
Yeah.
Then I think it will not qualify.
It will not qualify. Oh yeah. Oh yeah. Yes. Yes, please. Okay.
I think there's also not bias here because we are trying to find bias against women. So, do you understand what I mean? I mean, A and C is clearly biased, but B is not. So, selecting all of above is also, you know, sort of bias because we are trying to find bias.
Yes.
That is now confounding bias.
Yeah. Yeah. Again, it's very complicated. It's very complicated. What you think might be different from what I think. Someone might think, no, there's no bias in B, right? Yeah. It's open for discussion. All right. Yes, please, David.
How far, because I mean, we need to move room, I found. I managed to book the wrong room, so we need to move to another room. So is there a time, but we have for like 5 or 10 minutes?
Yeah, we can pause here.
Is it good time
Yes.
to pause, or do you want to round up or something? like this?
I don't know how
Because
my
if we-
slides are left. Pardon?
I think we can switch now.
We can switch now, right? Okay.
Okay, so you're finished your part then, or?
No.
No,
Oh, switch room now, you mean? I thought you meant switch between the two.
no, switch room.
Okay,
at this
then that's good.
point,
I think that what we'll do, maybe we take a coffee break
Yes.
upstairs and then we come back to the other room. Because I forgot that I booked a different room for this morning.
All right.
Now the students-
For the online people as well.
Yeah, what?
The break, that we have a break.
Oh, they'll have a break, yes.
Yes.
Yes, I'll share this. I'll say. Okay, so sorry for interrupting you so much. I just want to say, because I think that this was an amazing presentation of this material. I've heard these things talked about before, but I thought you really captured it very well. So thank you very much for that. I'll give it applause now. Very nice discussion. But for the people online, we are continuing, but we're going to have a break now we'll come back, I think, at 10:30.
Yeah.
And we'll be in a different room, but if you're online, then you don't notice. So we'll be back at 10:30 to continue this.
Yes,
Okay.
thank you.
Let's see if this one. Sorry. That's not good.
It's not projecting.
Oh, there we go. Okay, as soon as I.
So it's one. Okay.
So that's that, but the camera, can you see if the camera is there? So
Francesca is the
if you
camera.
do,
It was, okay. She could see.
she can see,
Yeah, she can
see you.
Yeah, see me on the Zoom.
Okay. So you can see, yeah,
I
that's
have
it.
to.
Okay, perfect. Then we're okay.
Okay, you
Good.
showed me earlier, so I think it's fine.
Then we are ready to continue. Please, Joyce.
Thank you, David. Welcome back, everyone from the break. So I'm going to wind up and then we'll get into the technical parts. It says resume share. Can you see my screen?
No.
Okay. Not my slides, right? All right, let me try to share again. I'm confused. I don't know what's happening. I'm trying to download it. It's not working. I'm not sure what's up. Okay, is that good? Okay, so I think we're going to start here. So because we are looking at languages and because the example that we're going to have is about languages, we thought we'd also talk a little bit around language and gender, right? Because we're looking at the lower level of machine translation. We need to understand the linguistic structures that are used to refer to different gender across languages. And I think that people who study languages know these things very, much better. And usually when we work on such projects in Makerere, we really collaborate with the Institute of African Languages to kind of help us understand the notations with languages that we are working with. So the first category of languages is referred to as the genderless languages, like Finnish, Turkish, Luganda. I think there's always the example in Turkish that's given around machine translation. And so in these languages, the gender-specific aspect of it is at minimum. You don't differentiate between males and females. We only express it at the basic lexical pairs, usually, for example, at kinship or address terms. So we don't have something around she, he, the pronouns. We don't have such things in genderless languages, but we can, have maybe words that differentiate a sister from a brother, that differentiate maybe terms that are created for that language, like a mother-in-law, a cousin, and sometimes even cousin is one word. Like in Luganda, if you're referring to a cousin, it's probably one word. Sometimes it could be the same word, although it's a male cousin or a female cousin. It's very hard to differentiate just looking at the words, what the gender is in the sentence. I think also from the example that we had in Luganda, the model was able to assign he or she because it didn't know what to pick at that point, because we just refer to the verb, like he's washing, the verb is washing, and then the model has to pick who is doing the washing of the clothes. Is it a female? Is it a male? That's the problem that we have with the genderless languages. Then the notional gender languages like Danish or English on top of the lexical grammar, which is mom, dad. The languages have other gender, pronominal gender, he, she, her, him, that represents the different expressions in the language. But also English has some hosts around different derivative nouns, and I think French as well. Actor, actress, chairman, chairwoman. We've seen all this in several examples. So even here, it's even better because then you have words that are defined for even roles that express both genders, both the female and the male gender. Then the third category are the grammatical gender languages like Arabic and Spanish. Here, each pronoun pertains to a class such as masculine, feminine, and neutral if it's present. So for example, the sentence, he or she is a good friend, has an expression of gender in a genderless language, like it has no expression of gender in a genderless language like Turkish. And unfortunately, I don't read Turkish, so I hope that's correct because I got it from Google Translate. But Spanish will spread several masculine or feminine markings around the translation to show that he, that she, around each of the different pronouns or all the different associations between the nouns that we have in the sentence. So there are languages that are really rich and spread out. So all these different notations around the languages are going to influence the way the models are going to work. So I'll now get into some just overview of work that has been done around gender bias mitigation. And I'll also leave the references because there's quite a lot out there of people who have attempted to look at this mitigation in literature. So there are comprehensive data resources that are critical in probing gender bias in a language. Usually when we have a machine learning problem, the first idea or the first place where we start is always on the data before we get to the algorithms, because anyhow, the data will influence what comes out from the model. So we already start with the data. So much of the work has also been around building these evaluation data sets to understand gender. So many of the data sets in NLP are usually inadequate for measuring gender bias because they're also gender in the models. And so when we are analyzing gender bias, we have to have a specific way or deal with specific data sets to understand the structure and include certain information to enable the proper association of the effect of gender in our models. So this slide talks about examples of data sets that are out there that have been used to probe gender bias. And I think for the people who are really interested in this, especially the masters and PhD students, I think these are very good data sets to get one started to understand different kinds of biases, because the data sets are there. If they're in English, that's even good. Then you just have to translate, for example, in your local language, and then maybe try to bring this out. So this is from a paper. The references are after the end. So there are data sets that have been created from different years. I think the one that's also usually used is the minor MT, but there are many, one minor gender. So different researchers build different data sets. The size says how big the data set is that was created, and then the data is where did these sentences come from. So some are human generated, some come from sentence templates, others come from Wikipedia. And then they also talk if gender is talked about in the data set, and then the task, what was the task for the data set that was created. But most importantly, the bias part says what was being investigated in the data set. So for example, the first one focuses on stereotyping. The next one focuses on occupational biases, because realize this occupational bias is a big one around males, females associating roles with different genders. So there's a very big, a lot of work that has been done in that area, more on stereotyping and then occupational bias as well. So if people are interested in particular biases, there are data sets that they can pick and investigate with. And we are going to show one of these examples, but for Luganda, and see how to evaluate this at the model level. So beyond just gender, we also have race and ethnicity, that these are really racial analogies and religious analogies that could be investigated. For example, associating Black with homeless, Asian with laborer, I don't know, Muslim with palace, or Muslim with war zone, or Christianity with intellectuality. There are many other associations that are out there that could be investigated. So just to think that it's not just about gender bias, but there are also other biases beyond gender at the text level, because we are looking today at the text level that could be investigated. So I think I will stop here for now and then have Andrew come in with the practical part of the course. Thank you.
No, but we're not in Zoom.
Start your video. Share your screen.
But if you send it to me, I still haven't got it.
I send it.
Yeah. Good, got it.
Share screen. See which one screen is it? Is that what you're seeing?
I think so, yeah. So just minimize that. And you can-
Okay, looks like we are ready to start. Could someone confirm the online audience can hear, see me?
Just change the camera so we can see all of you.
Yeah, please.
So we can see. If we have this camera plugged in, we should be able to maybe. No. Okay, well, I don't think we can do that, so we'll just move this slightly back. So then, yeah, the camera that you're using is that one. I wanted to change it, but I can't. 1 minute, maybe. It's off. Something. Yeah, good.
Okay, all right. So, yeah, I hope the first part of the session went well. You're convinced this is important to everyone, right? Yeah, I'm sure I didn't have to say that anyway, but just to be sure. So the way we think about machine translation work that we do, especially all the NLP work that we do, it's a foundation for applications that we build on top of that. So we tend to do a lot of applied type work, but we need to make sure that the foundation upon which we are building these applications is sound and not biased, right? So say you're doing an insurance application that is using NLP and suddenly thinks this man is a woman, right? That's major, right? So you need to be sure that the foundation is robust. So when we started out, responsible AI was not really a thing, right? But the moment you start touching the real world, it becomes apparent that this is something really important. So we actually stepped back. I think now it's been more than 6 months to try and fix these biases in the machine translation models that we have been building. So the way this is going to proceed today, I have 2 notebooks. I have shared the GitHub link to both notebooks. I hope you have all received those. They are well contained, so you can follow along, or you can decide to look at them beyond this session.
So say I have put them on the webpage for today's activity. So
yeah.
If you go into the CoRE-AI webpage where we've had the meeting program, they're available there, and then in the Zoom as well. They're available in the chat.
Yeah. So feel free to follow along if you're prepared, or just follow along with me as we move forward. So since I do not know I'm a bit aware that we have a very mixed audience. So I decided to first give a very short run through machine translation in very simple snapshots, really simulations of what the actual systems are like. Then we'll transition over to the bias evaluation. So historically, there are 3 major types of machine translation. The old school way, as we call it, is really the rule-based machine translation. So the idea here was that there are a number of ways of doing this, but really, if you have a source language and a target language, you have to create kind of a mapping construct that knows how to go from one language to another. Very manual process, right? You have to decide what rules map the source language into the target language. And that's why it was very, very hectic to build robust machine translation models in the past, right? So there is a difference between what we are seeing today, which is data-driven, and the previous incarnation, which was the rule-based approach. right? And in between that, you have the statistical machine translation approaches that were really the mainstay for years beyond the rule-based, before, of course, everything was upended by the deep learning based approaches, right? So when you talk about the rule-based approaches, there are a number of ways of doing this. You have the direct approach, which is the simplest, and it's what we'll talk about today. But you have more advanced scenarios, the transfer approach, where you build a rule set that is specific to the language pair you're dealing with. You also have the interlingual approach, where you build a neutral intermediate representation, which can enable you to translate between multiple languages. So I think that's interesting to know that, and also maybe to understand a bit where all this is coming from. So I have a very simple demonstration of really the most rudimentary machine translation, say, implementation that is based off of a dictionary. And it's not even translating sentences, it's rather translating words, right? But the important thing is that, so while this is a dictionary, in this case, it is also serving as that mapper that we talked about that knows how to go from one language to another. In this case, we have this dictionary, which is both our data set, weirdly, but also what is doing the mapping. So we have two words, hello and goodbye, right? And then we have how they are represented in the different languages. And we can base off this construct to go between these languages. You have English, Luganda, Choli, a number of languages. Of course, many of them are Ugandan languages because this is what we work with. But that should not deter you from adding Japanese or whatever you speak. You should be able to update this, and this very same framework should be able to work for you. And the first part of that is really going to show how easy it can be to do something like that. Right. So, and this is the workhorse of the whole thing. As you can imagine, if you can write some code, then you can write this thing, just really 6-7 lines of code. So essentially a function that takes the text, the source text, you have to specify which language it is in, and then the target language that you want. And then we can leverage this dictionary. If you say your source language is X, right? We can really map, if you say it's hello and it's in English, we know what that is. And then if you want to translate to another language, you can just pick the corresponding entry in that area. So really a very straightforward approach to doing the translation itself. And in this case, of course, Selfo here is showing translating hello from English to Luma server in this case. And we can see that, of course, this is very straightforward, right? But I guess that is a challenge. Whenever I see something so simple, maybe it's also very constrained in its application, right? But I think it's a good starting point to try and understand where the complexity can arise. So you can see that while this is simple, if I start translating sentences, it becomes very difficult, right? You have different run lengths given the different languages. Some languages even have different character sets. So your work becomes there in the middle, in the parser, in your rule set that you're creating, that it should be robust enough to move between one language to another. That means that it is going to be very difficult, right? You're going to have lots of if statements, if this, if that, if this. You're going to write thousands or even hundreds of thousands of lines of code to do a mapping between one language and another. And you're not even sure that you have covered the entire range of the grammar and syntax for the two language pairs that you're dealing with, right? So while this is great and all, this is not what we want. This is not where we want to be, right? I don't know how many years ago this is. I'm not a linguist, but quite a while back that people were looking at this. So I think one easy thing, and I thought this might be a good place for those who are interested in writing some code. I mean, it won't take more than 2 minutes. You can update the dictionary, right, and add an entry for your language of choice, and then just try this cell4 out to see if you can back translate between the languages that are already there, or translate back and forth between the languages that are there, and you're convinced that really this works for you, and it can be scaled out to different languages. So really a fairly simplistic way to the machine translation approach, right? So are people interested in just spending 1-2 minutes, making a change and testing it out? I think it might be fun to give it a shot. Yeah.
Come back in, what we say, 5 minutes.
Yeah, in about 5 minutes, then we'll be back. If someone has challenges in the room or online, we can definitely try to assist. Also, maybe to give some clarity, once you're done updating the dictionary, if you want to test out your addition, right? So you'd have to come and you can play around with these 3 things, right? But remember, we have a constrained vocabulary, right? That is determined by the dictionary. So you can't just put something random in there, right? But you can't select between any of the languages that are there. So one of them should at least be your own language, just to be sure that, and maybe another language that you can understand, if such that you're sure it is not lying to you somehow.
Yeah.
Oh, please remember to run the cells above first before you run the. Yeah, I think that's, I forgot to mention that. Yeah, if you want to see the nice colors. Anyway, if you want it to work at all in the first place. Is it working? Great. I think we have many people who have been successful at that. So yeah, first demo, check. So we can move on to the next one, if that's okay. Okay, I already mentioned this when I was introducing this, some of the limitations of this. Of course, human involvement and so on. If you're not a linguist, you're not going to be able to cover the range of that language, right? So I guess if it were up to the linguists, we wouldn't all be here today, right? So it means that even us today have some tricks up our sleeves that can enable us to do a lot more of that work. Now, the next generation of machine translation techniques is the statistical ones, right? So, and when you hear statistic, of course, think models, also think learning from data, right? So we are now kind of making a shift from rule-based, having to clearly define the boundary, to learning from the data that we have, right? So when you're looking at statistical machine translation, you're typically looking at two different models, right? You have the language model and the translation model, right? So the good thing is that these also translate to the later generations of these, right? So the language model, think of the language model as the language expert, right? So it is trained to understand the range of your language. So it is trained on the monolingual corpus. So that means that if I'm dealing with Swedish, I'm going to get a very large corpus of Swedish text. Then I learn from that text to understand what the correct structure of language should appear. And most importantly, which combination of characters are more likely to occur than others, right? Why is this important? Because the translation model is trained off parallel pairs, right? So you need the parallel corpus between the two languages. If you're looking at Swahili and English, you need to have Swahili on one side, the source. You need to have English on the other side. You train this translation model, again, by learning from data. We won't dig too deep into the details of how that works, but I'll give a simulation of how it could be in a simpler scenario, right? So this is how the two work together. Think of the translation model as a proposer, right? So after you're done with the training, the translation model tells you these are some of the potential ways that this translation could go, right? Maybe it gave you 5 different iterations. Book, boat, boy, or a boy bought a book, to give you like 5 of those, right? So which one of these is correct, right? Either we ask a linguist, but wait, we trained the language model, right? And the language model knows which of those sequences of characters is most likely to occur, right? So the language model is then going to look at those potential translations and tell us which one is most likely, and that's the one that we are going to pick, right? I hope that kind of gives a picture as to why you need these two things, right? The language model we are talking about now is actually exactly the same language, the way you train the same language model with the later neural machine translation techniques, or at least it serves the same purpose, right? So this, I think, was a very good segue into the newer neural machine translation models, right? There were a number of advantages, but still there are a number of limitations. The parallel data creation can be a nightmare. And I think they had some bounds around how much data you need, 2 million and so on. So depending on what you're comparing it with, this could be an advantage or a disadvantage. Can be pretty difficult to debug these models as well. So again, it was transitional. It was the mainstay for a while, but it was still quite untenable and still needed quite some level of understanding of the language structure. And then it typically falls flat when it comes to when the word order is off, right? Here is an example of English and Chinese. They are going to struggle with something like that. Whereas the newer techniques, like we are not going to talk a lot about the neural machine translation models because that can be very complex. But the idea is that they have alignment mechanisms that can deal with issues such as that to make sure that you can get the right ordering of your predictions out in the end. So I think that is a bit about the statistical machine translation. So if you look at, again, following from the same example, and you can keep your dictionary from before, this is, to be clear, is just a simulation of statistical machine translation. So don't take this and say, aha, I have built a statistical machine translation model. I can graduate now. No, none of that. So, so it is just an emulation that shows you some of the aspects that we mentioned about, especially that you can learn from the data that you have, right? Which is an important component of both these statistical techniques and the neural machine translation techniques. So again, this, what we are going to do is we are going to start with no knowledge, right? About our translations, right? And then we'll iterate over time, right? First, we'll be guessing all the time. We're like, okay, if you tell me to translate from Uganda to Swahili, this word, I just throw back a random answer, right? From the possible answers, right? But whenever I get the answer correct, right? I put that in what I know, right? Which is these land translations, right? A fairly simple function to understand, right? So if you try to predict the translation for a word and a language, right? It will first check if it already knows the correct answer for this, right? If it doesn't, it will look at the translation dictionary for that word, right? And just randomly pick any of those translations, right? So that's the first part of it, okay? So, and that's the workhorse of this entire operation. So essentially, we are going to be alternating between guessing and picking from what we already know. And if we do this many times, right, and I think you see where the statistics comes in, 100, here we are going to do 100. Of course, if you do 1,000, you're probably going to get better convergence for your model, right? In this case, the language model and translation model are abstracted by these land translations, right? So in this case, we pick a word, a language at random, try to predict if the translation is correct, because in this case, we know what we are training, so we know what the correct translation is, right? We just put that in what we know. So again, this is just putting in code what I was explaining before, that initially you're just guessing what the translation is, but whenever you get it right, you make sure you put it in memory, right? So if you do this over time, I put all this in one line because I think it's kind of compact and should be easy to understand in one shot. But I'm going to run it now. Then we'll look at what happens. I'm hoping there are people who know some of these languages here. So if we go to the very top, right? So here we are translating from Luma Saba. Am I missing something? Oh yeah, we are translating hello to Luma Saba, right? So we are going from English to Luma Sava, predicted Kulam Caesar, Joyce. This is Luganda, so no, we are off. Right? I don't know if there's Swahili here. Hello, is this correct? Yeah, so in this case, we got lucky and that was correct. And I think it also got that right. Did it converge very quickly?
Right.
Which one? Yeah, Kwaheri is also correct. Yeah, but you can see somewhere it's falling flat on its face. ATS, what's ATS? ATSO, right? It predicted Koizeo. The correct one is yoga, right? So initially there's a lot of guessing, Luganda, Agandi, Koizeo. You can see it is really all over the place, right? So now if we go to the very end, we should be seeing a lot more correct predictions, right? And you can see at the very bottom of our 100 iterations, we have converged. Again, not statistical machine translation, but it should imbue in you the idea of learning from data, right? That we can launch this. You can't add another language now, and the very same code should be able to converge and still update the entire system to be able to move between the different translations. So I think that very concept of learning from data, very important. And of course, this created the leaping stage for the next and current generation of state-of-the-art machine translation techniques. So in this case, I don't think we need all the 10 minutes. You already have the dictionary. If you run it, I'm sure you've already seen. So can anyone comment on what happened to their language? Did it fall flat on its face or? Victor? You're still checking. Yeah. So, but if all goes well, we should all have convergence at the end. Yeah. For Amharic, we are good. Yeah. So that's good.
Doesn't it go very slow at the end because it's got like it's got one last pair it has to see.
Mm-hmm.
So it gets very slow to learn the last one, is it?
Yeah, it is quite possible, but I think it also depends on the. Oh, okay. All right. So we had the question as whether it goes slower, the convergence slows down towards the end when you're looking for on two pairs. I think that's a very high probability of that happening, right? But I think it's also dependent on the nature of the randomness, right? That you get in that very scenario. You may end up in the unhappy path where you may need 1,000 more iterations to hit the mark, or like in this case where we were lucky and within those 100, we were able to align the two in that case. But I think that's a very valid comment about this.
Is it possibly due to the nature of implementation?
Of course, it is. And this is not how the real, yeah, you have actual models behind that are known to model language structure well that will be used. But I don't think that was the purpose of this, since we are really setting the stage for what we want to know about here today. Right. So, and then on to what we are dealing with today. Again, like I said, I'm not going to spend a lot of time on this, right? At least the introduction. The important thing to note, neural machine translation really means we are dealing with neural networks, right? And then we are doing sequence to sequence modeling, because that's the natural structure of language, right? It's sequences of characters, not translating one word at a time, right? And that, of course, presents all sorts of complications. Memory becomes important, context. There is a lot that comes into play that you have to account for. The architectures themselves tend to be encoder, decoder, right? That just means that whatever we pass in, when the network does not propagate sentences, right? It propagates numbers. So there are a number of steps that you have to go through to match what the model itself expects, right? So you encode whatever you have been passed into a certain representation, and then you prime the decoder to generate the output. I know most of you know a bit about this from this class, but if you need further resources to understand this better, we can. I think we have quite a number of resources in Joyce's slides that you can take a look at. But of course, you can't talk about this without talking about attention, right? So, and again, the important thing about attention, it gives us a few superpowers, but most important of which is that we can do longer sentences, longer translations, right? Because again, remember, as we're encoding, we are squeezing data into a small vector. So if you're not being careful, you're losing a lot of information in that encoding. So attention gives us back that by allowing us to look back as far as we need to get the context that we need to do the translation, right? So I think that is a very important part. And on top of that, it also offers us alignment. We briefly mentioned this, that languages do not have the same structure in which the characters will appear. So you definitely have to find a way to get proper alignment between the boundaries of the things that mean the same in the two languages, right? And that is also something that is enabled by this construct. The biggest challenge here is the data requirements, right? You need a lot of data, right? So we are trying to replace the linguist, right? So to be able to approximate where they are without going to do a PhD in linguistics, we need to collect that data, right? As such that our model can experience the entire universe of that language, right? That is very costly and also very challenging, right? So that is maybe one of the main challenges. There are quite a number of them. It looks bad, it is not, it's still the state of the art. But I guess that's why we're still working on this, right? One important thing that I would like to talk about, because someone asked about this, is regarding the domain adaptation, right? And I think Joyce can also comment on this. When we just got into language about 2-3 years ago, we were looking at, why don't we have machine translation models for our languages? We know AI, we can do this, right? We understand this attention thing. Where is the data? What is the quickest one you can think of where you can find alignment? The Bible, yes. I think that's what you mentioned as well. Guess what will happen if you train your machine translation model on the Bible? What will it be? To be a pastor, right? So it will tend to think in that way, because that's the universe that you showed it, right? So this issue of the domain also comes into play. If you're building a general purpose machine translation model, it has to see all the categories. It has to see all the different structures, right? Also, if you don't want one that speaks like it's from the medieval times, you need to use the text as it is today, right? If it's King James, it will be saying, I don't know how they used to speak those days, but you know what I'm talking about. If you show it that, that's what it will know, right? If you train one on agriculture data and you try to use it on health, maybe the diseases, it will tell you are crop diseases, not people diseases, right? So it's a very important thing to know when you're dealing with this. And one of the things that we try to do these days to surmount that gap is try to build domain-specific things. If we know this is the purpose for which we want these translations to be done, we know we can leverage resources for that one domain, right? We cannot cover the broad range of the language, but we can definitely cover that. And as we get more data, we can keep increasing what this MT model is capable of over time. Yes?
Just to corroborate what you said, our pidgin translator, because we use Bible as part of the corpus, so when we put a sentence that had London, no, London was on the Bible. We brought out Rome. But I don't know.
Yeah. So
still Rome as European city in the Bible. So brought out Rome.
Yeah, so I think that is a very important lesson. Even if you don't type any code today, remember that, right? Your model is as good as it is. There is some magic right? I guess magic is just that science has not caught up yet for some of the aspects. But you need to do the work. You need to show the model the right data. You need to train it the right way for it to be able to give you the fidelity of the translations that you expect. Okay, so that is a bit of what I wanted to say about the background and setting the stage for this before we can get into the gender bias evaluation work that is the crux of this. I don't know if at this point there are any comments, Solomon?
Yeah, just a comment for all of us actually. Most of the time, collecting the content, most of the time for Africa, I don't recommend you yourself to collect the data because you need some kinds of data which is already collected by the standard body and then put for research. The reason is because most of the research in Africa becomes really biased because the data collection itself might be biased so that, when you say it is recognized 90%, how do we know? Because even if data collection may not be correct. So I know there is many projects that are already involved in data collection for African language, text, speech, and videos, and everything. So it is better you try to find in any institutions in your country which has already collected the standard, and then you have to make sure that if there is nothing, then the second step will be, of course, you can collect the data, but you have to make sure you have to validate the data collection process, what you do is valid or not by collaborating with the linguistics department or any linguistic expert that and there is many methods where you can validate. So if you have that, then your research findings might be validated. So first of all, it's better you check the standard body where they have already prepared. Because I know the African Union has tried to do many projects to collect the corpuses for African languages. So make sure that they exist or not. If it is not, then whenever you collect the data scientifically, make sure that linguistics are validated with the process.
Yeah, thanks, Solomon, for that. So Solomon was alluding to the fact that if you're not prepared to address bias during your data collection, it is going to creep in. And if you measure at the end, it's too late, right? Because you've already spent the money to collect the data, and now it is already biased. So you have almost a useless product, right? So I think it's a very important thing to plan your data collection. I think Joyce also mentioned this, that we do not try to be experts at the language, right? We can't train the models, right? But when it comes to the protocols, the guidelines for the data collection, we go to the languages people, right? Because they are the ones who know how to address this. So we will never have a project where we are pretending to be language experts, right? And maybe another thing that we didn't, we were meant to present, but we didn't come out, maybe, or somehow we skipped it as we were removing things, is that the bias can enter your translation system at various points, right? It can be at the data point, at the input point, even at the training stage, right? If you're overlooking certain aspects of that, you have not optimized, or even at the inference stage, right? So there are many points at which a bias can attack you, right? So it means you have to have a plan on how to address and combat it throughout the process of your model training. So, and it all starts with the data, right? So again, thanks, Solomon, for bringing that forward. Yes.
I don't know whether it's a serious concern, because in most African settings, actually there is no standard text, or there is no data on most of these languages. And I think, for instance, of my mother tongue, which is Kikuyu, there are quite a number of very few text reference, except for the Bible. So probably, I don't know how that would be, but probably starting from our speech to text kind of approach, and then that would be probably a data collection point. and then curation, subsequent curation, because there might not be any standard reference database or data set.
Yeah.
For instance.
That's a very good point. Now I'll give you another anecdote about what you have just described. Yes, I'm going to repeat. So he's gave a comment that for most African languages, there's really no reference data. There's little to no data available to even start with. And he proposed an approach where maybe you use, say, speech to text, right, to generate the data, and then maybe you take it through a validation process, right? So when we started building our own machine translation models for Luganda, we were struggling with the data. Of course, we didn't know how difficult it was to even get 1,000 high quality sentences, right? We were very ambitious. We promised millions of sentences, give us 2 months. 2 months, we couldn't even find 50 good sentences. We had to get on our knees and tell the funders, please, we were wrong. So, but as we were thinking of ideas around that, we thought that Google had looked like they had come up with something, right? We were like, but if we can take some English data, throw it in Google Translate, gives us some Luganda translations, yeah, we can ramp up our data set very quickly. You know what's wrong with that? Not just the structure. Who can think of what could go wrong in such a scenario? So remembering that your language is low resourced.
Translation.
Bias. Thank you. Right? So you're actually just inheriting the biases from Google. Google does not have Luganda speaking people. If they have them, they're like 2 or 3 maybe, right? Or Kikuyu speakers, right? So they will do their best with the resources they find online, but they do not have the capability to curate them like you have said, right? Yeah, so you can't get the volumes of very terrible data that is going to add another year to your project, right? So there's no substitute for collecting high quality data from the start. So you're better off having a 1-year project. You spend 6 months figuring out a plan on how to collect good quality data, right? Than starting collecting volumes, which you have to throw away, right? 2 months to the end of the project. So it is very important to have that quality. And I like that Solomon mentioned validation. When we do our data collection these days, we usually have 3 levels of validation. Last week, we added another one on top of that, right? To be sure that it is quality, we are checking everything. We have very strict guidelines. We semi-automate the checks to make sure that we do not have to come back and fix mistakes that we have. Because each sentence is very expensive, right? Each sentence has been seen by maybe 3 experts at different levels of expertise, right? To make sure that we are doing it right, right? It is costly, but you would rather have a small high quality data that can take you part of the way than have something that you have no idea what its behavior is like. Yes. Yes, mostly. She asked about the procedure that we use for validation. Yeah. So we usually have, where it is possible, we can catch some errors through basic semi-automated techniques. So if there are syntax errors, there are some regex things that you can run, right? But from there on, it's humans all the way up.
Well, no, so why I ask is because it's actually very expensive, like you said, and tedious. So it will take a lot of time. But the good thing is when you've gotten it, you've gotten it.
Yeah.
For future use and for others. Like Joyce said yesterday, she said our children are going to buy these things that we are going to that, well, not that you're going to use money to pay.
Yeah.
To get from Google, right? You're giving it to Google. So Google will use it. The way your children grow up, they'll start searching for it and they'll go and pay and get it. And that's why we are losing in Africa.
Very interesting. Go ahead. Yeah.
I think you need to repeat that.
That's what I'm saying. So we have to come and heritage out. Yeah. And then they will buy the heritage when they grow up.
Yeah, I will. Yeah.
Right?
Yes,
I wanted to ask, do you try to do, for one sentence, do you only have a sentence here and just the same one single translation, or you have like a sentence in English, you can have like 3 sentences here. English, one translation, the same sentence in English, another translation. I'm just trying to see, because the translation we have different way of saying the sentence. So do you take that into consideration what you do? Or just you have one English sentence and one translation in your training set?
Okay, so I will comment on both. I know the first one was a hot potato bit. That there's this risk of us collecting data for our low resource languages for the big tech companies, right? They build the products and then they sell them to our to our children and the future generations. So I think that's a very, very interesting conversation, and we've been having a lot of this as well. It is something that we do struggle with. But let me first finish with the comment. But what we try to do is we always make sure that if we are negotiating a contract, I think if you're a researcher in a low resource setting, you have to do this. It is your right. And actually, you have the leverage. You may not know it. You may think you're sitting with Google, so they're scaring you with big money. No, you can't speak, right? Because you're the expert, right? So there's no way around you. That's the way to think about it. But always negotiate at least terms that allow you to still have research level access to that data. That is the first tier that I think. Do not do it the other way around. Next, as a researcher, and this helps you and your children, you also need to be building your own applications on top of the data that you're collecting, right? And who would know better how to build an agriculture recommendation system in Kikuyu than you, right? Will Google be able to know that this is the correct recommendation that has come out, right? So you have an edge in that expertise, right? So I think there's no very clear answer there, but don't sell yourself short, right? I think we have an opportunity to also have that impact. Maybe you sell back to Google, right? But you have kept 20, 30% of that, which you hand over to your kids. Right? Yeah. Yes. Okay.
And then they always announce that they don't say to the Dominican party that they use physical information for their own. Twitter, they report an API for the developer. If you ask them, they provide the information. But most of the time, they will give you farm which are already been done for people in the family.
Yeah, so thanks, Solomon. So I think that's a good point. You still have some. Yeah. Yeah, okay. Yes, Trevor.
Facebook, they have they will say for third parties. So if you want to buy, you can buy. But they don't give it to you for free. They used to give you an API so that you can have an access, that's not anymore. But once you get into the free, nowadays most of our people they try to collect the process. So most of the time we don't know exactly where it is. And for our body, for example, our university used to collect but we didn't know. Then when we tested, we found out that it's a data. So what I'm saying is, if it is English or if it is, yes, we can say it is no resources. But now I think most of the language in different institutions in their country, they might have it. So I just want you to try to find whether it exists or not. And then if there is, because now there is an issue called open data access, which we just want to ask all the universities in Africa whether they have a resource or not. and then to put it for access openly. So please try to find in your country whether there is a corpus which is already collected from the standby framework.
Yeah, so Solomon, thanks. I think the data thing has overtaken this talk. So what I suggest, two things. If you want to discuss more, I'm still here even tomorrow if you can catch up with me. Also, I think maybe this is one of the things CoRE-AI could take up as a track to really try to get to the bottom of this, because this is all driven by data. So if we can maybe have something in the framework of the consortium to address, have such conversations around
My
this. Yeah.
suggestion, Andrew, is that we maybe have a 15-minute break now.
Yeah.
And then you have 35 minutes at the end to talk about the last.
Okay.
Does that sound good?
Yeah, I appreciate it.
Yeah,
Thank
then
you.
I think that we'll do that. We'll. If you say this to the Zoom, you can tell the people online that we're having a 15-minute break and we'll come back. Yes.
Yeah, so folks online will be going for a 15-minute break, then we'll return for the last part of the demo session.
Okay.
I'll see you shortly. Yeah. All right, I hope everyone had a nice break. Apologies if we got too excited and ran through the break. I promise we'll be more mindful this time round. So I think now we can start talking about what we consider a case study of the work that we have been doing to address gender bias in a somewhat unique situation. Joyce mentioned this in her talk extensively, that you have this very interesting challenge when you have a language that has gender neutral pronouns, right? If you're translating from a language that does not have gender pronouns to one that has, so the model kind of has to randomly pick which of the two, right? So here I indicate, again, I'll try to move a bit slow, but the good thing is that whatever I write in Luganda, the equivalent you will see in English. So I hope it will not be so difficult to follow what's going on. So a good example here is that this is a sentence in Luganda, Umusawo Agambye Aja, right? So the pronoun, again, Luganda is kind of a weird, like other languages. So the pronoun is hidden in here. It's kind of agglutinative, meaning that it can combine many things into one word that are actually separate, right? But this translates to the doctor said he is coming, or the doctor said she is coming, right? So any of this is okay. And I didn't know it was weird until we started paying close attention to this. Of course, it seems very natural. You grow up speaking that way, right? You know from the context that he or she, but this is a big problem for machines. Machines don't like this kind of ambiguity, right? So what this translates into is bias, all sorts of bias, right? But today we are going to focus on gender bias because I think it is the one that is most harmful in these kinds of situations, right? Typically, of course, this comes as no surprise. It is going to pick the male version, right? Because it tends to see more of that, right? So again, in the spirit of statistics, right, the model picks the most likely translation. So it is going to zero in on that one, right? So you have to think differently about how you can track these biases, and most importantly, have a plan to address them, right? So for this session, we are going to focus on gender bias in Luganda-English translations, non-gendered to gendered pronouns, but involving occupations, right? Because I think that's one that we can all relate to. And again, Joyce made a very good exposition on some of these. We selected the translation gender bias index. I'm going to explain at a high level. I know not all of us are mathematical, but I think it's also fairly easy to grasp. There are other ways of addressing gender bias. For example, you can try to attack the embeddings themselves and debias them. That's another popular approach now, but this is one that I think is quite straightforward to understand, and you can easily trace back the points that are causing. So it's fairly explainable in short. And of course, this is something that you can again take as a framework and get your own language if it has these same characteristics, or modify that same. Actually, we have to modify it for our case. So if you have a more straightforward language, it's a bit easier to measure these kinds of things. So let's talk about the intuition behind this metric that we are going to use to measure gender bias in a machine translation model that we have trained, right? So how does this work? The math is there, but let's go straight to the intuition. So even if you're not trading this, this is how to think about it. So we went out, collected our payroll corpus. We collected our monolingual corpus and we trained a machine translation model that takes us from Luganda to English, right? Then we launched it and now we are in inference mode, right? So we put in whatever we want to translate and we get out what the model is showing us, right? So what all this is based on is that we need to track if in the process of translation, the model messes with the gender, right? If you can repeat that, then you have understood this metric because everything else is based off of that fact, right? If I gave it a sentence that, for example, this sentence that I gave it here, the Omusao Agambye Aja, right? If it gave me one of these, right? Then it has messed with the gender, right? Right? So this is a bias it has created. There are other ways of expressing the same thing without necessarily having to stick to one of those. Or if you want, be more specific about the gender when you provide the context for the gender in the sentence, right? So, but the whole point is that if we can track when the gender has been altered between the initial source sentence and the translation, then we can count the biases that we are getting, right? By just simply counting how many gendered pronouns are appearing in English for each sentence, right? We count those and then we just average out and we say, overall, maybe this model, 50% of the time, messes with the gender, right? I hope this is a clear concept, right? And the other part of it is that the higher it is, the way it has been defined here, the higher it is, the less biased the model is. It can be a bit counterintuitive, but if at 100%, you do not have gender bias, at 0, maximum bias, it has polluted the whole thing with gender problems. Okay? Yeah. We are going to do it together. Yeah. So you ask if it's manual or otherwise, you can automate it quite simply, actually. Yeah, you don't need any fancy machine learning tricks. For as long as you understand this concept, then you can reliably measure if the model you have built is creating bias. Okay? So I think that is the whole premise of this. If you understand the metric, the rest is just, we are going to be loading up 2 different types of models and see what they're actually doing to the source text that we give them to translate into the target language. Yes.
What PSI stands for, what this is like the bias function. Where when there is like bias, you can do one, and when there is no bias, you can do 0.
Yeah, so he was asking about PSI here. So yeah, that is also correct. So at the extreme ends, you flip either maximum bias or not. But in this case, this PSI is really just representing what that value is that is quantifying the proportion of the bias in set I, right? So it's just, if you go to the reference there, you can read the whole thing where I pulled it. Right, but it's just the proportion of the entire set. Yeah. Yeah, so you typically, you're going to see this, you have different sets that are looking for different things, right? So in one set, you can get a certain proportion. Let's say this set is hunting for when it should be saying this is a male gender translation, right? You can have a set that is focusing on that. Then you can have one that is focusing on female, and you can have one that is supposed to be neutral, and it still shouldn't mess with it. I don't know if that makes sense. And once you have all those,
say that if there is a bias or no bias, that's true. So the bias let's say, okay, there's bias, then it's 1, no bias, then it's 0. Then you count number of 1, the number of 0, then you make the average.
That's exactly what you do. Yeah. 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 So he was asking about how to distill this, but this is what mathematicians do for us. They take something like that and codify it into something which can turn into a line of code, right? So building a model of that is this, right? And the good thing, you said it yourself, you start with binary, but the actual answer is not going to be binary, right? Because you have counted and you have normalized. So you're going to get a range between 0 and 1. You can have two different models. One will be 40%, the other is 60%. So the actual framework is a count, but the metric is continuous, right? Mathematicians, I hope I didn't sweep my leg off accidentally for that. But you're exactly right about how we go about computing the metric. Okay, so now let's go in and start with this. Right, maybe just one other side concept. If you've not been working with language machine translation models a bit, is this blue score. I don't know exactly what the correct pronunciation is. It essentially just tells you the quality of the translation. It's essentially comparing what your model is producing to a human reference, right? So, and then it chooses n grams, how many of those word pairings match up between the two, right? And then it gives you one score. The higher that score is, the better your model is. And you can see there's a grading here. So the models we are dealing with are somewhere here, right? It's not that we do not want better models. This is where our data can take us so far, right? Because again, the data requirements also go up as you start chasing better and better performance. So again, there is that 80-20. Is it 80-20? Something like that. It applies, right? So when you see something like this, or when I comment, it gives an idea of the level of the model that the models that we are dealing with. So these are just some. I hope those who have this, you can already run some of these boilerplates. And again, for the statistics folks, the random seed, what does this do for us? Wait, I have a comment. Sorry, it doesn't hurt to explain what the seed does for us. Yeah. So again, they are statistical models, right? So if you don't fix them, they'll try to do whatever they want, right? So I may run this and I say, aha, we have solved bias. If you have a different bias, no bias. But of course, it introduces a number of other things, again, statistical in nature, that you can, if you have enough data, then regress to the mean. Okay, so these are commented out. These are the two models that we are going to be using, right? So the first model that says AI Lab, Makerere, Luganda-English is our base model, right? So that is the model we built before we knew that this was a big issue, right? So we have that base model. And then in the past, I think this year, we have this model that we have built by refining the other model to have less bias, okay? So we are going to be taking a look at those two models and try to compare the level of bias in each of those models, right? Using the metric that we outlined earlier. Which of these models is making more gender mishaps, which is the one that is trying to create chaos for us? Okay, so that is the exercise that the demo that we are going to be going through today. I'm not going to say exactly how the models were built too much, but again, transformers, self-attention layers, again, encoder, decoder with 8 attention heads. You can understand all these coders. Yeah, if you don't, I'll send you a link. You need to be to understand this to also benefit from this. So most of the state of the art look like this, and the good thing, if you know LLMs, again, just a larger version of this, right? yeah, with of course the emergent behavior that comes with the scale of the model. Right. Okay, let's just do this. Maybe load up the base model. These models are all on Hugging Face, right? Obviously, if you want, you can play around with them. This is all. Our work is mostly for social good. So anything you see and like, if it's not online, you can just send it to me. Right. So we have that model down, and I have just some sentences here that we can quickly translate to make sure that that the base model does as we expect. Right, so the first one just says, I saw your mother in the market yesterday, Joyce, and I think a few people know Luganda here, Prof. Quite impressive, super long one, but I think it still nailed it. Your daughter performed poorly. The last one, it kind of bungled, right? Oh, well, not right. But supposed to say the father is a quiet man, is a retired man. Could be, but not what we are looking for. Retired and quiet, maybe. But we need the direct translation. So of course you expect such things. Like I told you, this is not the highest quality of translation that we can get. But I think with this we have enough that for the applications that we care about. Okay, let's talk a little bit about how we are going to evaluate this. Right, and again, it's quite important how you construct the sets that you're going to use to evaluate the gender bias, right? So we have three sets. I'm going to first talk about the last two, then I'll come back to the first one. So the second set, so what we are checking is what happens. So remember Luganda is gender neutral, right? But we can't have context in the sentence that clearly says this must be a female translation. And this is a very easy one, right? We can't argue with that. If it says, again, remember we are dealing with occupations and yeah, to some extent, with occupations, we'll come to that bit. But the point is that if I get any sentence and I'm talking about someone and they're pregnant, right? I'll be shocked if it translates to this guy is pregnant, right? So even though they are not gendered pronouns, I know that with this context, I should get a feminine translation, female translation at the output, right? The same thing, here the Hakwas, we say, oh, let me scroll up such that you can get it, that this person has a wife. Okay, I know this is a bit slippery, but just bear with me. I didn't plan for the binary, and please forgive me. In the next iteration, we'll try to see how to deal with that, because even this was a hassle. So please don't be offended. But the point is that for these particular genders, again, the rest we are coming, for these particular genders, we can really knock it down, right? Guy with the wife. X is pregnant, right? So this context has provided us a way of checking that whatever we should see the other side must be translated to that gender, right? So if the model does not, then it is messing up, right? If it does not maintain that this sentence is feminine or masculine, then it has flipped our gender, right? I hope that's clear for those two. And then the first set is the one where we kind of leave it. It's neutral. We have no context, but we just want to see that if we do not provide it any context, how many of these sentences does it convert into masculine and how many into feminine? Is that clear? This is like everything from this talk, right? And this is just one way of doing this. Obviously, you can see many ways that you can create your test set to be able to measure the bias for your particular language. And of course, 3 is not the maximum. You can have as many as you need for as long as you think you have good coverage of what you need to learn about your translation model. Okay, maybe I'll take a quick pause if there are any comments, very quick ones and technical about this. It's clear? Okay, I think it's going well. So the rest of it is just setting up this machinery, right? So we are essentially, I pulled a number of occupations in English and their translations in Luganda to be able to construct sentences that are in this structure, right? That conform to the way we want our set to appear. So this is simply that. We have the occupation lists. Inside here, we just have these functions that you can see they're just simply appending. This is the open one. If I say the doctor is coming, could be female, could be male, right? So this is that first set. Then you have the second one, pregnant, we're on the second set. And then this, for the WEFE is the one that should be maintained as masculine, right? Again, remember the IJ is maintained. You need to maintain the, to preserve the gender of the sentence in the target language, right? If you want to see some of these are collapsible, you can just open collapse them and open them. So this is just running through and generating those. Okay, so now this is back to his query. How do we actually count? Super easy, right? You just check the target for the pronouns, right? And then we count how many of those ended up W's for woman. Okay. Yeah, the feminine one, N is man, and the N is for the neutral ones that should be preserved as is. Okay, so we are just getting proportions from our translations of how many of each type of those that we have, right? So it's just counting what he said, right? We go in here, like it said her, he, her this many times, said him this many times, and so on, right? Then we can build that proportion of the gender as it is available in the final translation. Okay, and this, right? Recognize this is the formula for our index, for our metric. Just this, right? So it's just an implementation of the metric. Okay, so obviously we'll start with the best model, like I said, before we try to do the debiasing, and then we'll just run through and generate a metric for the translations for the test sets. Okay, that loaded. I think these were dumped to disk, so we can load them up. Yeah, not very elegant, but we'll make it down. I just wanted to show just a sample of the sentences that are coming out. So this is an interesting one. So in this case, what we are doing, it's not really necessary, but this is the one that is neutral. We just ended up. So I'll come back to this maybe a little bit at the end, but we just ended up showing the model that the same sentence can be masculine or feminine, because initially it was not specified. So that's how that set is constructed. Then you run it through the translator. Let's just run through all these one after the other. Yeah, as you can imagine, again, no magic here, right? We have generated the translations. Next, we just need to do the counts, right? Of which pronouns have shown up in the final translations for each set. Then you also get that going. Yeah, of course, the translation takes some time. It's not a very big model, but it still takes a little bit of time. But that's the compute service step. Yeah, we have made it to set 2. Okay, this is already quite interesting, right? So the second set, C, right? Something is not right. It is translating, but what chaos is this, right? So this is, again, you can't tell. If you're not thinking this way, maybe you'll never even try to translate something that is to do with pregnancy, right? You're only focused on the problem you're trying to solve at the moment. Someone says, do you have an empty model? Of course, we're on top of that. You send them the link to the Hugging Face. And this is what they're using in their medical application. So, so this is, of course, going to be problematic. Give me something. The number of genders is right? So here it's just giving you the proportions that initially, remember set 1 is the one that is supposed to be neutral, right? But it's telling us that about 45%, this model just turns them into a masculine, right? Does this make sense? This have to add up to 1. The first one is the proportion. Remember what we sent in was neutral, right? And now we are counting, where did the pronouns end up? How did it modify them, right? It means that initially all the weight was here. When we translated, some of it shifted here, right? So this model is obviously biased to the male side. Right? The second one, I think, is even worse, right? Because this is the one that is supposed to be, this is the one to do with the pregnancies, right? But it has put all its weight on the male pronouns. So this model is really all for not a good model, essentially, right? And then the last one, slightly better, but still, we can see that the weights here are overpowering the others, even when they shouldn't be doing that, right? So, and this is that averaging. We are going to be averaging, and so we are just computing the index for the 3 sets, right? So out comes 0.46, right? Remember, our scale goes from 0 to 1, right? 1 is good, 0 is terrible, right? So we are on the side of terrible already, right? So I think that already gives us, and that's the beauty of metrics, that they can give you one number that you can try to work with backwards towards improving. Those who do optimization, I think that's important, right? You need to have your objective function produce a number such that you can optimize, right? So again, it is the same thing. You need that metric to give you a strong signal. So we got 46.7, right? Now, our goal was in the next phase, and all this work that we did was that, can we try to improve on this? And the way to think about this, any incremental improvement is better than leaving the model as it is. Yeah, okay. What I'm trying to say is that we haven't fully fixed the problem, obviously, but I'm going to show you what we are able to achieve. And I'll just spend 2 minutes talking about how we went about essentially building that model. So we do have to generate the translations again, because it's a different model. This, that, this remains the same, but let's run that. Now, as that comes, I will just talk about how we went about doing this. Briefly, if you want to hear more about our plan, then we are still here. You can come and talk to us about it. So one of the things that we did, the set that we used, of course, we took the model that we had, but we treated this as a domain adaptation problem, right? That essentially, what that means is that we do not want to change the translation characteristics of this model. We just want it to be more gender preserving, right? So we built a set, or we built a data set for the fine tuning that is just targeted at telling it, focusing on gender issues. Essentially telling it, if you have neutral, this is how you should translate. If something has context with essentially with the female, it should go into that. But most of you have done fine tuning, know that first step is very important, right? If you fine tune the model for 2 tasks in succession, and I think people have seen this all the time with the chat GPTs and so on. It is exciting in the beginning. As they start tweaking it behind to make it not say weird things, it starts becoming crap at the things we care about. Sorry, forgive the French, right? That's how it works, right? So if you just blindly fine tune, let's solve this gender bias thing, yeah, then you're going to lose the translation. And we clearly saw that. If you fine tune to solve the gender issue, the performance, your blue score is going down, right? So the fix for that, distillation, right? So you build an architecture like that. I don't know how many people know about distillation here, but it's a pretty standard technique, usually used for model compression, but it can also be used in scenarios like this, where you want to make changes to your model without losing so much in the performance that you had before. So essentially align you train based on, I think it's called response-based fine-tuning, right? Where you tune on the logics from the teacher model, which is now our best model, to fine-tune the student model, which is the model that we're evaluating now, right? To avoid that issue of catastrophic forgetting, multiple fine-tuning causing a degradation in the performance of the model. I hope this makes sense. We can talk a little bit more about this beyond the scope, but I just wanted to give you an idea about how you could go about addressing this. All right. We have improved. Let me clap for myself. Yeah. So we can see that we have moved, right? We are this above, we are no longer on the wrong side of gender. We're not there yet, but we are definitely moving in the right direction to be able to improve the gender performance, and we have a sure way of measuring the incremental improvements that we are adding as we train the model further. Yeah, that's what I had for you today. I don't know if there are any questions, but thanks so much for the interaction.
Yeah, but just say there's some homework there, I see, because maybe not, yeah, that's very nice. Maybe not everybody knows that they can download models on Hugging Face. You have some homework for people who can find the Swedish.
Oh, yes. Yeah, I think this should be fun. You can use this very same framework, right? You can go to Hugging Face and find you typically find the model there. Maybe not Kikuyu, but a broad range of languages. Swahili will be there, Swedish is obviously there. Pull the model, you just have to replace the translator aspects. The occupation dictionary, you just need to change from Luganda to your particular model. And I guess the last change that you'd have to make is, yeah, just run it. Of course, not blindly, right? You need to be aware of the structure.
Just leave it there, it should be fine.
It's because of the structure of our language, right? So you also have to think about the same thing when you're dealing with your specific case of the language. But I think it should be an interesting one for anyone to try out without having to really train a model before and get into the responsible AI game. Thank you so much. Yeah, have a good rest of the day.
One slide.
Oh, you have one slide, okay.
Yeah.
No, but I don't think there'll be any. I mean, it's literally you have 4 people to come and view, and there's nobody left. So. Good going. Thank you. Thank you.
Go ahead.
Okay, I need to see the question again now. And they're misunderstanding it. Yeah, maybe there's a question for the audience. Does English have gender neutral pronouns?
Only from 2 years ago. Yeah, really, they just started saying, now I write they.
Okay.
Yeah.
And before, when I was in school, they told me this was wrong, because I used to always write they, because it felt very natural for me.
Yeah.
Especially if I was doing something on a computer, because you don't know the person, and now it's okay to write.
Yes, so yeah, that's exactly the answer.
Not be.
Yeah, that for English, you have both the gendered and the neutral pronouns. So we are counting all of them. You're counting someone asks, what are you counting? So that's the answer to that. So we are counting the gendered, but we are also counting the ungendered, essentially. So yeah, that is the quick answer. Of course, if someone wants to follow up on this, we can definitely discuss it further. If there's some kind of issue with this, it can also be addressed through research after all. Yeah, thanks so much for that question as well.
Yeah, thanks, Andrew, for taking us through. So I'll just conclude because I wanted to show the references as well. So let's always be mindful of the different kinds of biases that we see in NLP models and the data. I think that we were very specific on what we did for Luganda because anyhow, it was a master's student work and we really tried to investigate a particular part of the models to really understand this. Also, let's explore the biasing techniques, but be very cautious. I don't think that it's possible to fully eliminate bias 100%. So we have to really be very cautious as we are doing this. It might work for Luganda, it might not work for another language. So let's take that into consideration, but also identify the biases that matter for your problem, your context, your language, and your test for these biases. And this is an iterative process. It's not like a one-off, it's an iterative process. As we said, we're going to keep improving our models. We were very happy when we were even able to have a translation model from Luganda to English, but then we learned that our language was gender neutral. So then things weren't working. Then we, explored the problem further. So it's always an iterative process that we try to do to improve. and then be very transparent about your model and its performance in different settings. Let's not think it works well for everything. Let's be transparent as much as possible. Yeah, and this is to thank the team. I think I forgot to add Conrad, but to thank the team that's doing this work in the labs, and those are the references. I just thought I would slash, I'll show this because there's a lot of work around mitigating gender biases in NLP, reviewing gender biases. There's quite a lot of work that has been done out there, and data sets that are available, that are out there that we can use. But most importantly, I wanted to point out number 6, because it's core to us, it's like our baby. So we started out, I think, during the lockdown, and we developed courses on open and unbiased AI training data. How do you create open and unbiased AI data? We have 5 courses, and they're talking about NLP data. How do you create NLP data? Because I think that's a thing that has really come out here. Then image data, then geospatial data. We looked at different data sets, but one of the modules or the courses here that's available is around what we just talked about, gender bias evaluation. So when we were told to do this, we had forgotten that we had a course already, which was quite short. This has helped us to expand on the work that we had done previously. So we were very excited that, oh, we had already begun to think about this. We've taken some time to go through this. And the course is available on a platform called Atinji, which is sponsored by GIZ. But what is cool is like there's the replication package. So you can actually take what we have done and put it in your language and put it in your context, and then modify the courses, because everything that we did is available on our GitHub repo as well. Yeah, so we wanted to say thank you for the opportunity to give our masterclass in Sweden. It's been really nice. We appreciate that.
Thank you very much.